All right, so section 6.2 is about radicals still. Okay, so 6.1 was about radicals. 6.2 is still going to be about radicals. 6.3 will be about radicals as well, but I think 6.3 we multiply them, which for a lot of people they find that easier. Adding and subtracting, not that it's difficult, but the thing about adding and subtracting radicals is that they work a lot like terms. So like normally you can get like a 2x and a 3x and add them together because they both have x's, right? Um, but with radicals, as long as the radical looks identical, then you can add them. So let me give you an example of what I'm talking about. So if I had 2 radical 3 plus 5 radical 3, my answer would be 8 radical 3. Notice how the radical 3 stays the same. It's just kind of like 2x plus 5x equals 8x, right? Same idea, like we do with variables. So the radical basically becomes kind of like a variable. Now, if I were to give you something that looked like 3 radical 2 plus 4 radical 3, let's say minus radical 2. Now, just so you know, the radical 2, it does have a 1 in front of it, okay? We don't write it, but there is a 1, a number of 1 in front of it. So if you want to put it there, you can. I'll put it there kind of like a little phantom 1 there, okay, that you don't see. But my answer for this would be, let me write this out. My like radicals are 3 radical 2 and radical 2. So I'm going to subtract it. 3 radical 2 minus 1 radical 2 is 2 radical 2. And then plus 4 radical 3. I can't put those together. They don't have the same radicals. Okay, the same square roots. Square root of 2, square root of 3, they're different. So I can't mess with them. It's the same as if I were to write 3x plus 4y minus x. Well, my answer would be 2x plus 4y, right? Same pattern. Same pattern. The like radicals are like the same variables, right? X's. And then the ones that are different radicals, they'll be different letters. So we shouldn't have a problem with the bottom part, 3x plus 4y minus x. We should be able to get 2x plus 4y. We've been doing that for years, right? So radicals are the same. They behave the same way. The only thing that's different, okay, the only thing that's different is that you may have to break down the radical to make things match. They don't always match right. So I'll show you one more kind of random example, and then we'll get into some of the homework. But if I were to tell you, like, what is square root of 8 plus, let's say, 5 square root of 2, initially you would say, well, I can't add those because square root of 8 and square root of 2 are not the same. But I can break down the square root of 8. Okay? The square root of 8 becomes the square root of 4 times 2. And I'll put plus 5 radical 2. And what's the square root of 4? That's 2. So this is 2 square root of 2 plus 5 square root of 2. And now they have the same radical. And if they have the same radical, I can add them together or subtract them. So 2 plus 5 is 7. This is 7 radical 2. All right, so let's kind of move into the homework, like I said, and I'll show you some that are given to you that are pretty easy, and then I'll show you guys some that are a little bit more complicated, but this is all going to be simplified, okay? So everything's going to be simplified. So they gave me negative radical 2 minus 3 radical 2 minus radical 5. Now, if you notice, there's a negative radical 2, there's a 3 radical 2. There's two things there that have radical 2, or square root of 2, however you want to say it, okay? And then one of them has a square root of 5. So not all of those terms are like radicals, okay? Two of them are like, the other one is different. So before I kind of say like, well, I give up on the other one, let's combine what I can right now. So negative radical 2 minus 3 radical 2, how much is that? Say again? It's negative what? I'm hearing some of you guys say it, but not loud enough. All right, negative 4 radical 2. And then this one, just leave it alone. Don't mess with it yet. Now, before you're like, I'm done, right? Let's move on. I got to ask myself, can I reduce radical 2? Like, can I make it any simpler? Not really. Can I make radical 5 any smaller? No, it's 1 times 5. Nothing. So I am done. That's it. Okay? So this is the answer to that problem. So this is what I mean, like treat them like terms, right? It's basically negative x minus 3x minus y, right? That's basically what it is. I combine my x terms, I left the y term by itself, and there you go. The only difference is when it's letters, you don't say, well, let me see if I can break down y into x, right? Like we don't do that. With radicals, we can. We can say like, okay, well, it's a square root of 20. Maybe I can break it down a little bit, okay? So here's one example of something like that. Now let me show you another one that's a little bit more complicated, but not like crazy difficult. So here's example number 2. It's going to be simplify again. These are all going to be simplified. And it's going to look like this. Negative 2 radical 8 plus 2 radical 20 plus 2 radical 5. So right now, none of these are like radicals. Okay, none of these match up. So in a sense, you're like, well, I can't do any of these. Okay, but I start looking at the radicals and I ask myself, well, can I break anything down? Right? So radical 8. Can I break down an 8? Well, we just did it, right? It's 4 times 2. So let me write it out. Okay. And just work through it slowly. So we go negative 2 square root 4 times 2. I like the number 4 because it has a square root. I'll be able to take that out. Plus 2 times, what about 20? 4 and 5. All right. Plus 2 times, what about 5 right here? Sorry, I said it and wrote it. Can I break down 5 anymore? No, it's a prime number. So you can't break down prime numbers anymore. So, all right. Notice the first and the second radical both have a 4 inside, which means I can I can take them out by taking their square root, okay? So when I take out the square root of 4, what does it become? A 2. So it's going to become negative 2 times 2, square root of 2. By the way, I'm showing all the work here. If you want to do it in your head, go ahead. Plus 2 times 2, square root of 5, plus 2, square root of 5. Now remember, I would never, like at this point in my life, I would never show that step that I just wrote. I would just say like the 4 comes out, becomes a 2, and say, okay, multiply it by 2, and then just write it out. I probably wouldn't do this step right here, okay? But it's up to you if you want. All right, negative 2 times 2 is negative 4 radical 2. 2 times 2 is 4 radical 5 plus 2 radical 5. Can I combine anything?
Yes.
What can I combine?
4 radical 5 squared.
All right, so those are my like terms, right? But we call them like radicals. So 4 plus 2 is 6. So here's my final answer. Negative 4 radical 2 plus 6 radical 5. I cannot break down a radical 2 or a radical 5 anymore. So that's just it. We're done. It's like having negative 4x plus 6y. Like that's it. They don't become negative 2xy. Like you can't combine those. So in its most basic form, this is not a terrible thing, right? It's just simplified a little bit, right? But of course, they always want to put letters in and stuff like that. So we'll do some like that. Let me do one more of these things, but it's going to be a cubed root. Okay? So let me see. Right now, I'll move it up. It's just, I try to leave enough room just in case people ask questions and they want more things. I can have some writing space in between there. So, all right. So example 3, simplify again. Remember, these are all homework problems for you guys. By the way, right now that I mentioned that, as I'm writing this out, on your homework, when I do a homework problem for you guys, try to see if you can do it again on your own. Don't just put like, well, Mr. V wrote x equals 1, so I'm going to put x equals 1 and I'm going to ignore it. Like, the homework is extra practice, right? And I am giving you the answers, but I would like it if you do it again. If you don't, I'm not taking away any points, okay? But it would be good practice for you to just try it again, right? And the reason why I'm telling you is because that way you can check your work and see if you did it right, because I already did it for you, right? So, make sure you guys try it out. Now, remember, cubed roots can have negatives inside, okay? And I don't know if you noticed it, but whenever you do a cubed root with a negative inside, the negative just basically goes outside. So if you guys don't mind, I'm going to simplify it really quick without doing too much. I'm just going to rewrite it like this. Negative 2 cubed root of 16 minus 2 cubed root of 2. Okay? Cubed roots can have negatives inside, and when you take a cube root of a negative, the negative just goes out. Okay? So I just took it out. All right? I just took it out. Can I combine these the way they are right now? No. Okay? They both need to either be 16s on the inside or both have to be 2s. Okay? So I can't simplify the cubed root of 2. All right? It's just 1 times 2. 2 does not have a cubed root. But 16... Are there any two numbers that I could multiply that make it 16, but one of those two has a cubed root? 8 and 2, right? Because what's the cube root of 8? It's 2, right? So cubed root of 8 times 2 minus 2 cubed root of 2. And we know that 8 has a cubed root of 2. Right, remember, 8 is one of those numbers I told you to know for cubed roots. I said 1, 8, 27, 64, 125. Those are the 5 you guys should have in your head. Most commonly used cubed roots. Okay? The most commonly used square roots are 1, 4, 9, 16, 25, 36, 49. Like, there's a lot of them, and a lot of people know those, right? Because people aren't scared of the squares. Like, they've done those for many years. But the cubes, they're kind of new. So when the 8 goes out, it becomes a 2, so it's going to be negative 2 times 2. Again, I'm showing you an extra step. You don't need to write it out if you don't want to. But there it is. I put a little star there. That's kind of a little extra that you don't need. Negative 2 times 2, that's negative 4. So this will be negative 4 cubed root of 2 minus 2 cubed root of 2. Can I combine those? Yeah, they look the same now on the radical, right? The cubed root of 2 and a cubed root of 2, that means it's like the same letter, right? It's like negative 4x minus 2x, right? Same letter. So we have the same radical. So negative 4 cubed root of 2 minus 2 cubed root of 2 is negative 6 cubed root of 2. By the way, sometimes people say, like, can these things ever cancel out and your answer is 0? They could. It could go away. So, how are we feeling? We okay? Not too bad, hopefully. All right. All right. So I'm gonna turn this thing over. Thankfully, for this homework assignment, there's no variables in the homework. Okay, no variables, all numbers. All right. So, but they do start to get a little bit more complicated. So I will do one that's like, I guess you could say, really complicated. Then I'll do one that's not so bad. Okay. But here we go. If you guys have questions on something, just stop me, let me know. Right now, I'll move this up again. This will be 4, I think. Simplify. Okay, I'm going to do this one. This one's going to look worse than the last one, but I think this one will be easier in terms of like little steps. So we'll see. Negative cubed root of 16 minus cubed root of 2 minus cubed root of 2 minus cubed root of 16. There's 2 of them that are kind of like this, okay? Again, I know it's a lot of stuff, but don't get intimidated by it, a step at a time, little piece at a time, all right? Trust me, math gets a lot worse than this, and that's the same thing I tell my calc students, like, don't just, so if you get a Big Mac, you don't try to eat it in one bite. Well, some people do. But you don't try to eat it in one bite, right? You try to eat it slowly over time. Like the same thing with math. You don't try to take it all down at once, right? Pieces at a time, right? So, all right. So right now, I can combine a couple of things to make it easier on myself. Instead of having 4 terms, I can make it into just 2 terms. Okay? I see and I'll highlight this, the negative cubed root of 16 and this negative cubed root of 16. By the way, these won't cancel. Okay? And then I see the negative cubed root of 2 and this negative cubed root of 2. So those are like radicals. So let me combine my negative cubed root of 16 minus a cubed root of 16. That comes out to negative 2 cubed root of 16. I just took care of the yellow stuff, okay? Now let's take care of the green stuff. Negative cubed root of 2 minus a cubed root of 2 is negative 2 cubed root of 2. All right, so now I made it into 2 things. Now I'm going to say, well, am I finished? Well, I look at my cubed roots. I have a cubed root of 16 and a cubed root of 2. The cubed root of 2 cannot be simplified, but the cubed root of 16 can, right? We just did it. We made it into 8 times 2. This will be negative 2 cubed root 8 times 2 minus 2 cubed root of 2. And we know the cube root of 8 is 2, so we'll take it out. Again, I'm going to show this step, but I'll put a little star next to it, meaning like you don't have to do that step. But this is the little extra step here, just to show the flow of the work. So that comes out to negative 4 cube root of 2 minus 2 cube root of 2. Since they are like radicals, I can put them together. Negative 4 minus 2 is negative 6. This becomes negative 6 cube root of 2, and I'm done. I almost kind of wish that the lesson 6.1 was filled with a lot of, not this type of problem, but a lot of like these, just 2 cube root of 16, no letters and stuff, but they always put letters in it. But I always wish it would just be numbers at first to get you used to it. But they like to throw everything at you guys in that section, so not a big fan of it, but I mean, it is what it is. All right, are we good with this one? Because we got one more. Like I said, this next one's going to look easier. Well, it has less terms, so it's going to look easier, but in reality, it might be more work. So here we go. Again, I'm going to write it towards the bottom, but I will move it up right now. So it's example number 5, simplify. And it looks like this. Negative 2 cubed root of 24. Notice most of the ones that I said they're a little tougher, they seem to be cubed roots, right? So I'm gonna try to put stuff together than I can, like right now, just so I can clean it up a little bit. And then after that, I'll start breaking stuff down. So what can I combine? The first 2, right? The first 2 right here. These are both cube roots of 24, right? So I can combine the cube roots of 24. So negative 2 cube root of 24 minus 1 cube root of 24 is negative 3 cube root of 24. Then notice I'm put plus 2 cube root of 32. I moved the negative inside of the cubed root. I moved it out. You can do that with odd indices. So like cubed root, 5th root, 7th root. You can always move those out. Okay? At this point, I'm going to start to figure out what I can do. Okay? So give me 2 numbers that give me 24. 8 and 3. And 8 has a nice cubed root. What about 2 numbers that give me 32?
60.
Well, 6 times,
16.
well, Oh, 16 times 2, but 16 doesn't have a cubed root. But that is true, though. 16 times 2 does give me 32. Someone said another one. 8 and 4. We can use 8 again, right? 8 and 4 gives you 32. 8 has a cubed root, right? So here we go. Let me rewrite this. Negative 3 cubed root of 8 times 3 plus 2 cubed root of 8 times 4. And I like using 8 because it has a cubed root. If I could use 27 or 64, 125, those are great numbers, okay, because they do have cube roots. So I'm going to move the 8 out of both of them. Again, here's a step that is not necessary. You don't have to write it down if you don't want to. You can just do it in your head. When the 8 comes out, it becomes a 2. So it's negative 3 times 2, cubed root of 3, excuse me, plus 2 times 2, cubed root of 4. So if you skip that step, it should look like this. Negative 6 cubed root of 3 plus 4 cubed root of 4. Can I simplify the cubed root of 3 or the cubed root of 4 anymore? No. If it was a square root, I could do the square root of 4. That'd be fine. There's a cubed root. So I'm done. That's the end of this problem. Okay? So that's where I'm going to stop. Again, for your homework, I know I did this for you already, but try them again, right? Because I know you only have 11 problems. I just did 5, which means you only do 6. But like if you saw one and you're like, that one was kind of tricky, let me try it, right? Try it. And you already have the answer, so you should be good. And just one quick correction, guys. Notice at the very end, at the very first example I wrote, you can see it's in red. 2 plus 5 is 7.
Good morning, Mr.